ax squared plus bx plus c. Notice over here it says f of x, but it's putting these sliders in, a, b, and c, which you can change, so you can see how do these different constants affect the parabola. So my first question to you two and everybody, tell me what does a do, and use the sliders to figure it out.
Controls width.
That's it?
Isn't it it's a shrinker?
What kind of shrink? Horizontal or vertical?
Horizontal.
Well, it's kind of both, because you could technically get that a somehow inside the square. Right now it's outside the square. So technically it's affecting both. But notice if it's just a horizontal shrink, or a vertical stretch, or horizontal shrink, or whatever, do it again.
The vertex wouldn't change, right?
Right. It would just kind of raise all the lines up. That's because we also have an x in the equation. All right? Now, I think you didn't get jiggy enough with it. Boom! What happened?
When a becomes negative, it inverts the graph.
Right. And what's going on there, Emma?
Oh, when a is 0, it's a line.
What happens when a equals 0?
It's a line.
It's a line. Okay. All right. Now let's get back to our normal parabola. How does a, this coefficient x squared, affect the parabola?
It affects it.
It affects it. Is this a happy or sad parabola?
It's a happy parabola
When?
when it's positive.
When a is positive. There you go. And of course then, first of all,
It's not happy when it's negative.
it's negative, what happens when it's 0? Class?
There's no parabola.
Line.
It's a line. It's a line. Does that have to be a horizontal line?
No.
No. It just loses its x squaredness, and so it goes back to bx plus c, which is a line. Okay, well, let's guide us on what the heck b does. Mess around with it. What's going on with b?
So just wait, it's moving it around the average function.
Yeah. It's moving it around the y-intercept.
Yeah, but does it change the y-intercept?
No.
No. Change the vertex, right?
Yeah.
So the coefficient x does affect the vertex. It also looks like it affects where the roots are. Notice how suddenly you have roots. Right? Can you get just one root on there, one? Boom. Okay. Okay, let's get a couple roots again. So what does b affect, Will?
The vertex, and it shifts it over the y-intercept or something.
And what's that thing that goes through the vertex called?
The axis of symmetry.
Axis of symmetry, so it's also affecting the axis of symmetry. Okay, finally, C.
It's just the y-intercept.
Changes the y-intercept.
Just the y-intercept, right?
Well, and the vertex, but there you go.
No, it just changes the y-intercept.
Correct.
It looks like C is the y value of the y-intercept.
Okay. Notice when it doesn't change.
It doesn't change like the width of the parabola, like where it's going.
It doesn't change the shape of the parabola, it just moves it. So
Okay.
translating it.
Yeah, so it's what kind of translation? Vertical. And that's what you do when you're adding c. It's ax squared plus bx plus c. So it's something plus c. So it's going to be a vertical shift up and down. What's its effect on the axis of symmetry?
It doesn't affect it at all.
Doesn't affect it at all.
It's
Because,
just
so
long.
what are the coefficients that affected the axis of symmetry?
A and B.
Did A affect it? No, try again. Does A affect the axis of symmetry? Oh, yeah. Yeah, it definitely changed it. Okay. Now here's the toughest question. How do you get roots? This one has no roots. Why doesn't it have roots?
Because the vertex is above 0, so there isn't any x-intercept.
Oh, two ideas. The vertex is above 0, above the x-axis, and
There are no real x-intercepts
why not?
because the vertex is above 0.
Okay, I challenge that.
All right, no.
This vertex is above 0.
Because
No,
it's above 0 and it's also
That's
positive.
opening upward.
Right, exactly. It's got a positive A. So you've got the vertex above the axis and a positive A.
Or the vertex below the axis and a positive A, or a negative A.
So we've got a handy formula. Do you know the handy formula for where the vertex is? That would be part of the rest of the notes, because it's kind of hard to see from here. But we know the two variables that affect it now. In ax squared plus bx plus c, what affects where the axis of symmetry is?
A and C.
No?
No, A, B.
A and B. A and B. So the formula's got to involve A and B. All right. Cut. I'm going to have to splice this all together.
Oh, yeah.
But this is quadratic functions in standard or vertex form, where you have it like this. See the vertex form up there? fx equals a times x minus h squared plus k. We're going to try and figure out what each one of those things does. So first of all, let's see what the A does, okay? Maddie, you ready?
Wait, I
See
have
that
to
slider?
do these?
See that slider?
Maddie?
See the slider? Grab it. Grab it. Grab with your finger and slide it around. Whoa! Whoa! Keep sliding around. Oh, see now, what you have to do is keep your finger right on the slider. If you start trying to move the slider, yeah, I can help you out. Move the slider around. There you go. There you go. See how it's changing? Whoa.
Yep.
Sometimes it has to, sometimes it doesn't. Okay, so that's my question to you. What does A do in this equation? A times x minus h plus k. Now, so these things are called sliders. Here's the equation over here, but here's the general form of the equation down here. A times x minus h squared plus k. What is the A doing to the whole graph?
When A is positive, it makes
Yeah, catch the speed.
the parabola open up, and when A is negative, it makes the parabola open down.
Up and down. Do you agree?
Great.
Okay, here's the question then. Predict then what will happen if A is either positive or negative?
It'll be a flat line.
Flat line. That's what Keller says. Try it. Adam, why don't you try with the precision of that too?
All right.
It's a little hard to get it right at flat line at 0. So that's now, next thing, okay? Libby's turn.
I got it.
What do the H and K do? Mess with those. Mess with the H and K. What's going on with the H and K? She's sliding that around and she's changing the H. She's trying to slide K around. Now slide K around. There you go, sliding the K around.
Okay.
It's the X
Maddie.
values.
Here, I'll.
Yeah,
Okay.
thanks. Not
Okay,
good.
Adam's sliding the K around. What does sliding the K around do, Libby?
Y values, changes the Y values.
How does it change the shape?
It doesn't.
Okay. How about the H?
What is this?
How about the H?
The X values.
Yeah, the X values. Yeah, good question. What's that root thing?
Yeah, I don't know.
It's just where the intercepts are.
Intercepts what?
X center.
X.
Or
X intercepts are called roots. Y intercepts are a special name for that.
That's Y.
Okay? Okay, so what affects where the axis of symmetry is? Which one of those sliders? A, H, or K?
H. K.
Okay, H definitely seems to move it. Now try moving K. Does K change it?
No, it's a
No, but it does change the vertex. How about A? Does A change
Oh wait, what are we trying to
the axis of symmetry?
Oh.
In this case, no. Okay, but you're going to find in the other case we just looked at, it did change the axis of symmetry. But here we've incorporated the H into this. And what type of translation is this? X minus 3.4.
Horizontal
Horizontal which way?
to the right.
Yeah, so this is taking it 3.4 to the right, and then this minus 0.4. What kind of translation? 0.4 down. There you go. Okay, that's enough for this form. This is called the vertex form because, how do you get the vertex? Here it says the vertex
Well, the vertex
is this purple point here. It's 4, negative 0.4. Where does that come from? HK. Okay? H and K.
Yeah, it's like
All
a
right.
circle. Wait, it comes from center.
Right.
H and K like this.
But a big difference between the circle and the parabola. HK is the center on the circle. That is a point not actually on the circle in the center,
Yeah.
which is on the parabola. HK is actually on the parabola with this.
Yeah.
All right, now we're ready to shift gears and look at another form. And that is, call it up on this file here, the file. Quadratic function. Okay. You ready to go, Kelly? It's Kelly's turn.
Alright.
How did Kelly get up here? Okay.
I switched to Maddie.
Switch.
Maddie.
Okay, Kelly's turn. Now you have factored form, and you got three constants. And it's, the general form is a times x minus root 1 times x minus root 2. Is this still a parabola?
Yes.
Why?
Because it has two roots.
Okay, it has two roots.
Is this
Good.
one squared?
And it'll be still x squared if you were to expand it out. But we're going to see some of the advantages of having it factored. Mess with the a here and tell us what a is doing. Oh,
Change the vertex.
changes the vertex. Yep. It's changing the y-intercept too. But it's what we call the concavity. And remember what Adam said before. If a is positive, then what?
It opens up.
Concave up. And if a is negative, negative, negative.
Down.
Concave down. What if it's right at 0?
Line. Oh.
I got it.
Right
I
at
got
0.
it. Oh, no, I don't.
Oh gosh.
Okay, I got you.
Oh gosh. A right at 0, you get a flat line. Okay. Now, it doesn't have to be a horizontal line. In this case, yes. Because if you zero out the equation here, if you make a equal 0, then the whole thing becomes 0. But this a is the same a from the other two forms as well. And the other two forms, it doesn't quite zero everything out. Okay. Let's get a normal again. Just something positive, yeah. Now, maybe you're going to tell us about root 1, root 2. R1 and R2.
Yep.
What do those refer to?
X and Y.
No. Mess with them.
Backward.
Mess with R1. What happens? Uh-oh. Uh-oh.
Oh my gosh.
What are you changing?
This is just overwhelming.
The slope.
Changing like everything.
Changing everything. But what do roots mean?
You're changing where the x.
Oh, where the intersections are.
So the intersections are with the x-axis, right?
Yeah. Oh.
I got it.
Yeah. It's just not going well for me.
Okay, now let's split out. Let's get a root that's negative and a root that's positive. And make it a nice crisp number so you can see it.
-1.
-1, okay, that's one root. Now make the other root bigger. Yeah. Try making it 3.
Okay. Yep.
We'll go up to
I got
3.
this. I got this.
Okay. Make it exactly 3.
And now
I want 3.
Yeah.
Now, that's the advantage of factored form. It quickly tells you where the roots are, right? X plus 1, x minus 3, so the roots are at -1 and 3. It doesn't quite so quickly tell you where this y-intercept is. Look at this y-intercept. It's the purple one here, -1.8. Where's -1.8 in this formula? How would you get the y-intercept when it's like this?
Are we talking about like on our calculator or by hand?
No, by hand, how would you get the y-intercept on any function?
You set x to 0.
Set x to 0, so if you put 0 in for these two, you get 1 times -3, -3 times 0.6, and -1.8. Okay? So all these forms have a little advantage somewhere along the lines, right? And the vertex form is so handy because it told you hk. What are you going to do here to find this vertex at 1, -2.4? How are you going to get this x coordinate of the vertex? Which one of these sliders is it? Is it A? That's 0.6.
But isn't that the one that's moving the...
Wait, how do you get it? What was the question?
How do you get where the x coordinate of the vertex is? Where's that axis of symmetry in relationship to your constants here? Which constants are going to help you find them?
It's the median or the.
Your
It's
root.
like the average.
The roots tell you,
Root.
but does the axis of symmetry go through the roots?
No.
Where does it go through?
It goes to the
The
middle.
vertex is
The midpoint of the roots. Okay, does that look right? Halfway between -1 and 3 is 2. So these affect where the axis of symmetry is, right? Does A affect where the axis of symmetry is?
No.
In this form, let's see. Oh,
No, it's not.
no, did not change. The roots still stay where they are, you just change the shape of it, right?
Yeah.
Okay, great, that's our start. I'll try and get that all edited in.